Today we're going to be looking at the different shapes that graphs can take depending on the distribution of their data. So specifically we're going to be talking about symmetric, flat, and graphs that have skewed distributions. So if you take a look at these three, we're going to see examples of two skewed and a symmetric graph. When I take a look at how the graph is outlined, or I outline it, I can just kind of follow my line along with this graph, and I can see that if I take the graph and kind of split it in half, I can see that most of my data is going to be on the right-hand side of the graph. So if I follow this up and over, I have what's called a tail coming off the left-hand side of the graph. If most of the data is on the right-hand side of the graph, the tail is going to extend off of the left side of the graph. And that's how this graph is going to get its name. This graph for this data is going to be said to be a skewed left graph. If I come over to this one, skip the middle one for a minute, and do the same thing, I go up and over and then down, 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 down. I get a tail that extends to the right. If my tail extends to the right, it means that most of my data, so in this case the average of the data, is going to be on the left-hand side. So most of the data is on the left-hand side. So this would be skewed right. It seems a little backward that it's given the name of a skewed right graph when most of the data is on the left, but remember, it gets the name based off of which end the tail extends off of. And the tail is simply going to be like it's going downhill, right? And so it's just going to extend off to the left, or off to the right. And then over here, it's going to go downhill from the top data down to the bottom, and it's going to extend to the left. So if it extends to the left, it's skewed left. If the tail extends to the right, it's a skewed right graph. So now let's go here to this middle graph, and you can see that if I start at the top and I go down, and I start at the top and go down the other way, I get something that looks very like a mirror image. So if I were to take the halfway point in this graph, I could see that this data has almost as much on the right-hand side of the graph as it does on the left. And this would be called a symmetric data display. Now, to be labeled a symmetric data display, it doesn't mean it has to be an exact mirror image of data on the right or the left, but it should be pretty close. The one we haven't talked about yet is a flat graph, and I'm just going to kind of squeeze that one in here. So if you've got a graph in which your data kind of does something that looks like this, where you can't really differentiate that there's much shape to the graph at all, and it just kind of makes this flat line, that is called a flat graph. You can also call it a uniform. Flat or uniform graphs are also symmetric. All right, so you can show data in a bar graph like these, or you can show it in a dot plot, such as we have here. And again, if you take and just kind of trace the graph, I've got 5 data points here, so the halfway point would be here. If I were to just identify that halfway point, I can easily see that most of my data is on the left, and my tail is extending off to the right, so this would be a skewed right, because the tail is extending off to the right. And here, I go up and then down the other side, and my tail comes off the left, so this would be skewed left. And once again, The halfway point is going to be here at about 3, and so I can see that most of my data points are on the right hand side, so the tail comes down off of the left. All right, the other thing we need to talk about in this lesson is just a review of making a histogram chart and then interpreting how the data is displayed to see if it's skewed right, skewed left, or symmetric. So I've gotten the chart started. Of course, we're going to put frequency, okay, and then ages down here. All right, so I've looked to see that my frequency goes from a pretty low number of 3 to a high number of 40. I am going to go up by 5s. Start with my origin at 0. And I get up to my highest data point. And then my ranges, of course, I need to make sure I evenly space them out. I've got 10 to 19. 20 to 29, 30 to 39, 40 to 49, and 60 to 69. All right, and then when you put your data in, get as close to you as you can to the number where it should be. So this should be representing 3 or thereabouts. 20 to 29 should be 18, which is going to be, I don't know, somewhere in here. '30 to 39 will be 36. '40 to 49 is 40. '50 to 59 is 14. And 60 to 69 is 5. Okay, so that was just a little bit of a refresher on how to take data and turn it into a histogram. And so now you can go ahead and kind of, here's the top data, and you can come down, it goes there, and then here's the top of the data, and it comes down, and it goes there. So this is the case where you can't obviously tell that there's more data on the right or the left. It kind of takes that mountain shape that we talked about earlier. So this is going to be a symmetric graph. All right, sorry for the break in the video there. I just wanted to show a couple of different examples of how these look when you take them from the data chart and turn them into the histogram. And so we take these quiz scores in this graph, and you go from top to the bottom, and here we've got another example of a symmetric graph, because you really can't tell, obviously, that there's more data on the left or the right. Okay, so now we're going to look at home runs hit. So you can see that we have a frequency of 11. We had 11 occurrences of 11 to 199 home runs, 5 occurrences of 200 to 299 home runs, so on and so forth. When we put these into the graph, by even looking at it right away, I can see that this graph has data skewed on one side of the graph than the other. So I go from the top and just kind of extend this down. My tail is extending off to the right, and most of my data is clearly on the left. But remember, we name it based off of where that tail extends, and it's extending off of the right. And so this one is a skewed right graph. And then we'll look at one more quiz data, or quiz scores, and you can see some grades. And I've already drawn onto here that even without drawing it, you can see that most of our data is going to be on the right-hand side of this graph. And as our tail shows, it indeed does that as it goes down this slope here, and it extends off the left. So I've taken my quiz scores, turned them into a histogram, and then I can label this one a skewed left graph. All right, so 10.4 will be tomorrow, and that will be box and whisker plots, and then we'll be wrapping up this unit.